Okay, so after computing the summary statistic for 5 systems, now we can talk or represent our 5 system using graphs. So the suitable graph we can use is box plots. So some general observation about our data using box plots. So these are called box plots. You can generate this using R program, or you can use it some online links in order to sketch box plots. So from box plots we can see that system 1 has higher emission in general compared to others, and system 4 has the lowest one. And if you see that the boxes in system 1 and system 2 are bigger, so it means the variability in the data for system 1 and 2 are more variable. Now we'll talk about the variation of the variability. There are two sources of variation in Anova. One is called variation between the groups, and another one is called variation within the groups. These are used in order to find the statistics. So we should understand what we mean by SSB and SSW. So first of all, what is variation? If you remember, we have studied variance. What is variance or sample variance? Sample variance is computed by the sum of deviation of x from the mean and the whole square divided by, if we talk about the sample, then we have to divide by the total number of sample minus 1. Now let's consider that this data, you have it, they are not classified, okay? They belong into one group. Regardless of their system, they are just one group of data. They are just raw data. Now, in order to compute the variance for these data, what we need to do, we have to get the mean, first of all. And how do you get the mean? We get the mean by summation of all x's divided by n. So in this case, n will be the total number. So suppose you are not looking at the system, only you are looking on the values you have for emissions. So here now your n will be 20, and the summation of x, you total all these and you get the summation. Now what we mean by the sample variance here, we subtract each value from the mean value, whatever your mean value, and we square it, we divide it by n minus 1. Now this numerator, we call it sum of square of total, okay? Sum of square of total, because we have not considered the system, we are just talking about the data itself, regardless which system they refer to. So the numerator, this is called also as a variation, okay, in total, the variation in total. And the sum of the square of total, they can be divided into two sums. Sum of square of total can be divided into two sums. Sum of square of between the group and sum of square within the group. So what we mean by this formula, we mean that the variation in our data in total can be divided into variation between the system, between the 5 systems, plus the variation within the system. So what we mean by between and within? Between, for example, if you see that we have 5 systems, so now we will talk about SSB, variation between the system. If you observed previously that we computed the mean for each system, what we have observed that the mean are not identical in each system. The sample mean for system 1 is different than system 2, different than in system 3, 4, and 5. So there is a source of variability between the system or between the group. That source of variability, we can compute it and we can put it in sum of square between the systems. So the variation between the systems. Okay. Now, if we talk about sum of square within, just take one of the system. Let's say system 1. If you look at system 1, for example, you can observe that the value in system 1 also not identical. So there is a variation also within one system. So that can be computed by taking a system and compute the variation within the values of the system. So that is the difference between sum of square between and sum of square within. And in general, Anova variation is divided into 2 variations. The source of variation is the variation between the groups, and between the groups comes due to the factor, and the variation within the group. And this comes, why we get the variation within the groups, this can be explained by error in the variations. Okay, one system there might be some error, that's why the values are different. Now how we compute this, first of all you should understand that Anova there is a table. The first column in the table you write that we have 2 sources of variation. One is between, another one is within, and then the total. You need to compute the SS for between, SS for within, and SS for the total. Then you need to compute the degree of freedom for between and within and the total. Then after computing these 2, you divide the SS, the sum of square between, you divide it by its degree of freedom to get the mean square, MS. So just divide this by this, you get the MS. And again, for SS within, you divide it by degree of freedom, you get MS within. So when you have this MS between and MS within, you can find the test statistic, which is the F value. So how do we compute the first one, SS between and SS within? What you need? First of all, you need to compute the grand mean. How do you compute the grand mean? You take the sample size for each group or each system, you multiply it by sample mean. So we know that the sample size for system 1 is 4, and we have already computed the sample mean for system 1, which was 96. Again, plus sample size was 4 for second group, second system, and the sample mean was 89.5. These all values you can get it from the table which we found it here. Okay, so 4 times 96 plus 4 times 90 plus 4 times and so on. Then you can get the values of your grand mean. Once you have done that, you can get the grand mean. So once you have done that, what you need to do in order to get the SSB? So SSB is computed by subtracting the sample mean of each group or each system from the grand mean, which you found it in the previous step, and multiply that by sample size. We know that the sample size in this question, the sample size are equal. We have 4 observations in each system. So that's what we did here. 96 is the sample mean for system 1. We subtracted from the grand mean, that is grand mean, we found it, and then we multiplied by the sample size. Similarly, sample mean for system 2 was 89.5, subtracted from the grand mean, square it, multiplied by 4, and so on for sample 3, sample 4, and sample 5. You add all these, what you get at the end, that is called SSB, sum of the square of B, between groups. Okay, that variation between the group. Now how to get the variation within the group? The summation of degree of freedom of each system multiplied by the system sample variance. So if you go back to your table which we found the sample variance, what we need to do, we have to see the degree of freedom of each system. What is the degree of freedom? Each system we have 4 observations. So the degree of freedom for system 1 is 4 minus 1 multiplied by the sample variance. So that is sample variance, that is S1, okay? And then S1, sample variance for system 1. Then again system 2, again we have 4 observations, so 4 minus 1. And you multiply by the sample variance for system 2. And so on till sample variance for system 5 squared. Once you add all these, so what you get 305.01. This is called SSW. So once we found SSB and SSW, then we have to find degree of freedom for between the system and degree of freedom within the system or within the group. Now when we talk about between the system, the degree of freedom will be what? We know that we have 5 systems. So the total number of systems is 5. So the degree of freedom will be 5 minus 1, which will be 4. Within the system, each system, so now we are talking about each system. Within the system, in each system we have 4 observations. The degree of freedom of system 1 we have is 4 minus 1. Again, degree of freedom for system 2 is 4 minus 1. So, and then for system 3 is 4 minus 1. And then for system 4 is 4 minus 1. And for system 5 is 4 minus 1. So what we observe that within degree of freedom will be 4 minus 1 is 3. So 3 plus 3 plus 3 plus 3 plus 3. So total we have 15. Total degree of freedom in within is 15. And SS total and the total degree, if we add between and within, we get 19. And this 19 represents total number of observation. As you remember when I told about the sample variance for in general, we said that we have sample variance for in general, we have divided by 19 because total number of observation is 20, so 20 minus 1 is 19. So you must get here, the number you get it here should be the total number of observation you have subtracted by 1, that is 19. Okay. Now once you get the degree of freedom, you can get MS. What is MS? MS is just